In the dead of night, something moves through the sky. With no sound, no warning, and no radar signature. It slips through the most heavily defended airspace on Earth, delivers a payload powerful enough to change the course of a conflict, and disappears without a trace. This is the B-2 Spirit, a $2 billion ghost, a machine so advanced that even decades after its first flight, much of its technology remains classified. But how do you make something the size of a football field invisible to radar? To understand that, we need to go back to the Cold War. It's the 1970s, and tensions between the United States and the Soviet Union are at their peak. Nuclear deterrence is the foundation of global stability, and one of America's most important tools is its fleet of strategic bombers, especially the B-52 Stratofortress. These aircraft were designed to carry massive nuclear payloads across continents, remaining on constant alert and ready to launch at a moment's notice, acting as both a visible reminder of power and a critical part of preventing war. But as technology advanced, a serious problem began to emerge. Soviet air defense systems were improving rapidly, with radar networks becoming more precise and capable of detecting aircraft at longer ranges and with greater accuracy. Surface-to-air missiles evolved into fast, highly effective weapons that could engage targets at high altitude, turning what was once a reliable strategy into something dangerously outdated. In a real conflict, large bombers would be detected long before reaching their targets, and many might never make it back. So instead of trying to build faster bombers or stronger defenses, engineers took a completely different approach. What if the aircraft didn't need to fight its way through enemy airspace at all, and could simply pass through undetected? This idea led to the Advanced Technology Bomber program, one of the most ambitious and secretive engineering efforts ever undertaken, with a goal that was simple in theory but incredibly difficult in practice. Create a bomber capable of penetrating the most heavily defended airspace on Earth without ever being seen. But the foundation for this idea actually existed decades earlier. In the 1940s, engineer Jack Northrop believed that the most efficient aircraft design was the flying wing, an aircraft made almost entirely of one smooth, continuous surface. Without a traditional fuselage or tail, this design reduced drag, improved range, and increased aerodynamic efficiency, while also offering a hidden advantage, reflecting far less radar energy than conventional aircraft. Northrop put this idea to the test with the YB-49, a jet-powered flying wing that looked far ahead of its time, featuring a massive wingspan and a futuristic design. But there was one major flaw: stability. Without modern computers to constantly adjust its flight, the aircraft was extremely difficult to control, often unpredictable and at times dangerous. In 1949, the program was canceled and the aircraft were destroyed, marking the end of the flying wing, at least for the time being. Decades later, technology finally caught up. Advances in digital flight control systems, materials science, and aerodynamics made it possible to revisit the flying wing concept. And when the Advanced Technology Bomber program began, that design returned not as an experiment, but as the core of a revolutionary new aircraft. This time, it would succeed. The B-2's design is what makes it truly extraordinary. Unlike conventional aircraft, it has no fuselage, no tail, and no vertical stabilizers, existing instead as one continuous, smoothly blended wing. This shape is critical for stealth because radar systems work by sending out signals that bounce off objects and return to the source. Traditional aircraft reflect these signals clearly, making them easy to detect. But the B-2's curved surfaces scatter those signals away, dramatically reducing how much energy is sent back. But shape alone isn't enough. The surface of the aircraft is coated in specialized radar-absorbing materials designed to absorb electromagnetic waves rather than reflect them. Every panel is carefully aligned, every seam minimized, and every edge engineered to avoid creating detectable reflections, because even small imperfections could increase its radar signature. The result is a massive aircraft with an incredibly small radar cross-section, often compared to something as small as a bird. Then there's the challenge of actually flying it. Flying wings are naturally unstable, constantly shifting and difficult to control, but the B-2 solves this with an advanced fly-by-wire system controlled by onboard computers. These systems make continuous adjustments in real time, keeping the aircraft stable and balanced, and without this level of control, the aircraft simply wouldn't be flyable. In many ways, the B-2 is as much a flying computer as it is a bomber. The engines are also carefully concealed within the body of the aircraft, with air intakes placed on top of the wing to reduce visibility from below, while the exhaust is spread across a wide area to reduce heat. This minimizes the aircraft's infrared signature, making it harder to detect with heat-seeking systems, and ensures that every element of the design works toward the same goal, avoiding detection across every possible spectrum. Despite all this focus on stealth, the B-2 is still an incredibly powerful bomber. It can carry up to 20 tons of weapons, including both conventional and nuclear payloads, and is capable of striking multiple targets in a single mission using precision-guided munitions. Its combination of stealth and firepower allows it to operate in environments where other aircraft simply couldn't survive. Its range is equally impressive. On a single fuel load, the B-2 can fly over 11,000 kilometers, and with aerial refueling, it can reach virtually any target on the planet. It operates at high altitude and is flown by just 2 crew members, a pilot and a mission commander, supported by advanced systems that manage navigation, targeting, and flight control. But all of this capability comes at an enormous cost. Each B-2 costs around $2 billion, making it the most expensive aircraft ever built, and with only 21 produced, the cost per unit increased even further. Maintaining the aircraft is also extremely expensive, especially due to the need to constantly maintain and reapply its stealth coatings, while its complex systems require continuous upgrades to remain effective. Even so, the impact of the B-2 is undeniable. It didn't just improve bomber design, it completely redefined it, proving that stealth wasn't just a theoretical concept, but a practical and powerful advantage in modern warfare. It changed how air forces think about survivability, strategy, and the future of aerial combat. And now, as advanced as it still is, the B-2 is gradually being replaced by the next generation, the B-21 Raider, an aircraft designed to build on everything the B-21 introduced while being more efficient, more adaptable, and easier to produce in larger numbers. It represents the next step in stealth technology. But the legacy of the B-2 spirit is already secure. It stands as one of the most ambitious engineering achievements in aviation history, a machine that turned an impossible idea into reality. A bomber that doesn't just fly through enemy defenses, but disappears inside them.